Let's see if I can get a link to the stream here. Why is it not showing up? This is a little weird. So maybe if I pull it up on here. Okay, so we are live. It does actually work. I just couldn't find it. Okay, so where we ended up last time was I had written everything that was necessary to do a little mining with Blocklame, right? And we stopped there and we had said, we have this design for a networking protocol, kind of know what we want to do there. We want to expose self via kind of REST API or REST interface that allows you to do two things. So one is querying for blocks individually, and also broadcasting individual blocks. Now that I think about it a little more, there should be two things that trigger block broadcast. One should be when you're queried for one, and one should be when you mine a new block or you receive one. So there should be three, actually. Let's see. Let's write this down. So wait a second. Sorry, I had a visitor. Okay, so block broadcasts are triggered by either mining a new block, in which case we just send that new block to everybody in our known network, right? Or we can receive a broadcast from someone else. Hang on, someone is also coming up now. So when you receive a new block, you then query everybody else in the local network. You maintain a record of who you've already queried and gotten responses from. And you're querying them for the latest index in their local ledgers. And if that index is greater than or equal to the current block, then you disregard it. If it's greater than, you then initiate the fork update transaction. Or you could just have them, you could send the new block's address or index and then have them return a Boolean response. Even better, you could issue out the index that triggers them to then query from you the latest block. That's probably what we should do. Well, we could, let's see. We need a terminal condition. We just broadcast the block to everybody. I think we can just broadcast the block to everybody, and then every time we receive a new block that we already have, we can just disregard it because it's not a new block, so it's not new enough to solicit a fork update. Yeah, I think that works. So when we receive a new block from another node, we broadcast it out to everyone else. You don't have to worry about circular conditions because as soon as people start receiving the same block again, you'll receive it twice every time a broadcast is made across the network. But upon the second receipt, you stop propagating it through, and so everybody just gets it exactly twice. Well, maybe more. You'll actually get it up to as many times as you're known. But that's fine. It just aids in network connectivity. And it probably won't be a big network anyway. So for checking it for validity. No. And with this, if you just keep it as stated, like when you do a fork update, you issue all the updated blocks in the new fork to all of your known nodes in the local network anyway, so that also aids with transparency. So that covers broadcasts. You either broadcast when you receive a new block or you mine a new block. And then outside of that, you have queries. and there's only one type of query, and you just issue the index, which should be a positive integer. So now we need to define two routes. They look like the following. This one should issue, and it should provide an index equals n, and so on and so forth. Should be an escape HTML string. Let's see. All right, so we can pretty easily define these routes. Just have to do it in the main file over here. So let's do that. Let's go to main. Networking, actually. I think that's the file we had done this for. So we don't want to have a mine route. That doesn't make any sense, really. What we want is a request, a query. Oh, Copilot generate not found. Nice. Let's try reloading. That's pretty annoying. All right. So I haven't used it on this computer yet, so I actually have to authorize this thing. Now that's done, so I can have it suggest. So query, that's pretty cool. It kind of does precisely what I want it to. So now we just need to write this piece, right? So def query. What we want to do now is queries the node for a particular block, for a block by index on the specified index. I don't have to remember the syntax at all. So if request method equals get, we do this. I mean, this right here, this is exactly what I wanted, right? So this right here should just be converting it to an integer. And then that works, like that's all you need. I mean, seriously, like you don't have to do anything else. So now we also need to write the issue route, right? That's cool. I like that. Let's do this too. Like I want to have consistency in formatting. So I never use single quotes because they're ugly and they're used for characters in every other language. And I am not subscribing to this convention just for Python, right? Like we're not doing that. So issue. And we could just write the comment for now. Issues a block to the node, whatever. So this is really quite good. We'll just leave this undone right now. It stops there. What the hell? So now, I mean, we can literally just test this, right? Like I can start a Flask server. Let's see, does this have tmux? No. Really, I don't even need tmux, right? Like I can just open 2 terminals here. Yeah, let's not do that. So I'm not sure how it's going to work with a Chromebook. So to do this, let me get my streaming software to render properly again. Okay, works. So now to do this, I need to start up a Flask server. So we need to pip install Flask, I guess. Pip install upgrade pip. We're not going to do that just yet. If ever. Okay. So this should actually be app. So we did something wrong in blockchain.py. It's on line 23. Yeah. Okay. So we never actually re-implemented this thing. We're not going to. Domain error. .py. It's cool that it got the right type of error there, right? Like, and it, oh my God, it even suggested the correct return value just arbitrarily. How did it know that? We're running. Now I should be able to query this thing, right? And that's going to be at this local address. So we're going to open up another terminal. Actually, what I'm going to do is I'm going to go over to I'm going to start at mining. So Flask app run code in the background, I guess. I'm taking a phone call. 1 second. All right, I keep getting like endless interruptions. I'm about to have to run and then resume elsewhere. Maybe we'll see. But what I was gonna do was write a separate thread here, right? So I needed to have mining going on in the background during all this stuff. So how they do it here is they do threading. So Python multiprocessing versus threading, which one's better? I don't remember at all. Threads run in the same memory space while processes have separate memory. This makes it harder to share objects between processes with multiprocessing. So what we want to do, I'm thinking, is probably just use threading. Because, I mean, most of the time we're not going to be receiving events. And we could just pause our mining while we do receive events anyway. We don't need super crazy efficiency here because, I mean, if you do, you can write your own thing and you can probably just implement it in like Julia or C or something. So what I'm going to do is import threads or threading. So here we go. And now come on, suggest something. Oh, did it stop again? All right, this is the most annoying thing about Copilot I've found. Like, it kind of breaks in code spaces. All right, like after, I don't know, maybe like 40 minutes or so, it just stops working for no reason. And I don't know if it does that locally if I were to install it on Visual Studio Code, but it is really annoying when I'm doing stuff in the browser. Like, especially now with this Chromebook, like it takes a pretty long time to reload the page, and it eats up a lot of memory, and it's kind of frustrating, you know. So that's something I'd rather not have to deal with, but I guess I have to. Let's see what it says for if. I'm not sure if this is the right, like, I was thinking, like, maybe name would be like app or something, you know, instead of name equals main, because that's a little weird. Like, I would think it would kind of inject a new context for Flask. Okay, distractions are over. Let's see. So I want if name equals main. We're going to do this. And before that, what we're going to do is we're going to start a new thread. This should actually say app instead. And here, what we want to do is block mining in a separate thread. Yep, that's right. That's sick. Okay, so does this have mine? It does not. So we actually need to implement that. So I'm not sure what kind of data I want to store on the blockchain. For now, it doesn't really matter because I can just kill it and then start over again. Oh, that's not true. Because if I do so, then other people are going to have... I'll never catch up, right? Like, I'll have to mine faster than other people. So once the protocol is, like, finished, that's it. Like, there's nothing else to be done. I mean, I can just make an updated version and say, you guys who are using this old one are stupid, but... we'll do this. So if there's 0, yep, that's what we want to do. Now, we don't want to sleep. So if I go back, this should do what I want. There's the mine member. No, it does. Okay. And it's not going to persist when we shut down the app. Like, it's going to start mining over again. And additionally, that's so cool. It just does exactly what I want. Like I said, if debug, and it spit out exactly the message I wanted to do. Like it understands what I'm trying to get at. So this should just straight up work, right? Why is it not working? Oh yeah, I have to supply an argument, right? So this should be that, right? That didn't work. So arguments. Let's put that back like it was. So debug. It's true. Now I'm gonna go back here. So it never begins right mining, right? Or if it tends as if it's not. Yeah, so that thread's never getting started. Okay. So I think this might, no, that can't be the problem. Interesting. So I think actually what's happening is when we call Flask on this Python thing, this module, it's skipping over. It's injecting name as something else, right? So it's never reaching this little block right here. So what we have to do is manually do this outside that block. It should work. Yep. That's so cool. What on earth? So now while it's doing this, I should be able to query this node for any kind of data from the blockchain I'd like. Right? So it's actually working. Like we're actively mining this blockchain right now. So now what I want to do lame coin comment. I mean, we have to do it, don't we? Like, I have to take that and run with it. So now this we're generating blocks, so I should be able to go to like some kind of REST thing, right? Somewhere. Let's share the screen. Okay. So I should be able to go to REST query website. I don't know. Recommend, that's what I'm looking for. So I need to grab this port right here. We're up to 52 so far, 53 now. So this is what I want. And we should be able to just plug in this thing, right? And this should be query. And we should be able to ask for index, I don't know, 20. I need to manually supply this, right? So index equals 1 or 0. Let's do 0. Let's see what the server thinks. It doesn't think anything, so I need to just open this, frankly. And then I don't need to supply a port because it just includes that there. And we can just do query index equals 0. So now it sends back this whole mess, which is not at all what I want. There's something horribly wrong here. Object of type block is not JSON serializable. So how to make a class JSON serializable? We need to probably make like an underscore JSON. F name. JSON encoder. That might work. That might do the trick right there. So let's go back to block. Hash lib. So HIJ. Yeah. Why did it break again? JSON. All right. So from JSON, import JSON encoder. And this should be a JSON encoder. Right. So we've mined up to 64 and we're stopping there. Now I'm going to issue that same request. So it still says block is not JSON serializable. Aha. So now we need to write that little extra piece, which was default, right? Maybe that'll work. Still says not serializable. So this is not going to work. However, I do have an idea. We can just provide the string, right? That's really all we need to do. So whenever we're going in this route over here, the query route, instead of doing this, we can just do the string. All right, so that does work. Blockchain dot blocks index. So I actually want to print this, and I want to print exactly what this is. All right, so the reason I'm doing this is because I want to see those null bytes, make sure they're actually being represented in what's being sent across the network. Okay, they are. So that's precisely correct. Which is nice because now we can see that things are going properly. Like everything is working as expected. I mean, there is the timestamp. So we have the index, the timestamp, we have the data, and we have, I guess that's the previous hash. Yeah, that's the previous hash. So now this is a little weird to me. Right? Like, why is this going on? And that's the nonce at the end. Okay. That is so odd. The nonce is 0 on the first one. Then we have the hash. Yeah, that works. really we should be hashing an empty string for the first one. So every time we create this first block, we should be placing in it this thing, right? Oh, come on. Okay. So in this case, the very first node should be 0. It does have a hash. This one is incorrect. Why is it supplying 1 in this case? This should be exactly as it had stated for me before. It was indexing the blockchain properly without my intervention before I did anything. Now we're able to properly access this thing, read all the blocks. So what happens if I provide, say, 1,000? Well, it's only at 37. Yep, error. Now if I go back to 36, it's able to provide exactly what I asked for. That's quite good. Quite good. So now, let's see, 40. Good. It's a nice nonce. It's having to go up to like 1 million on some of these. It's pretty sweet. Yeah, so we need to do this still. And we need to do this still. But, I mean, literally, as soon as we get those two done, the blockchain will function properly and we can literally just, like, go live. So this, I mean, this is part 2. I'm just going to leave it at that because I do have things I need to go do now. But when we do part 3, I should get broadcasting working. Like, or issues working. And at that point, I mean, the whole thing works. Like, we'll have a functioning blockchain. We'll be able to go live with it. And that's it. So, yeah, we'll conclude this in part 3, and that shouldn't take very long, maybe 2 or 3 hours at most, and we'll go live. I'll publish all this stuff on GitHub, and other people will be able to download it and play around with it. Hopefully this has been a little bit elucidative. Is there anything else? I would like to also work on some kind of transaction system, but I don't know that that's going to be interesting enough to warrant doing. I'd like to, in a future stream, possibly after the next part of this Blocklame dev stream, is to work on some autoencoders. So I want to do some projects on auto-encoding PDFs and EPUBs and deja vu files and so on and so forth for making my digital library smaller. Because I have a lot of like online books, and I'd like to compress them, and I'd like to have a way to like do that without reliance on external tools. I want to like program it from scratch in JAX or NumPy or something. So we'll probably start on that in the next couple of weeks or so. Maybe earlier, but we'll see. And I guess that ends this stream, so I'm going to go ahead and close the stream. See ya.